Kimi K2.7-Code has the kind of spec sheet that makes coding agent people pay attention: open weights, a 256K context window, tool use, vision, and pricing that looks cheap enough to rerun. This is fluid coding and AI, and the real question is simpler: does it lower the cost of getting a correct repo patch? The headline version is easy. Moonshot says K2.7-Code improves over K2.6, uses about 30% fewer reasoning tokens on average, and is built for long-horizon coding work. That sounds great, but for agents, a cheaper token is only useful if the model can keep editing coherently after tool calls, failed commands, stale assumptions, and the usual repo weirdness. So I am measuring the story against one standard: cost per successful engineering task, not cost per enthusiastic release note. The model itself is serious infrastructure. The card describes a mixture of expert system with about 1 trillion total parameters, 32 billion active per token, and a 256K context window. Moonshot also says the repository code and model weights are released under a modified MIT license, with deployment paths through engines like SGLang, K-Transformers, VLLM, and Docker Model Runner. That matters. This is not just an API SKU. It is also an open weight option for teams that can actually operate large model serving. Hosted access is where the practical picture gets messier. Kimi's own API uses an OpenAI-compatible format with the model string Kimi K2.7-Code. There is also a high-speed variant advertised around 180 tokens per second, and sometimes higher in short context scenarios. Cloudflare exposes the model on Workers AI with function calling, reasoning, vision, and structured outputs. OpenRouter lists its own route and pricing. So whenever you see a benchmark or a cost number, ask the boring but important question: which provider, which harness, and which API contract? Here is where my expectation changed. DeepSWE v1.1 gives Kimi K2.7-Code a much more grounded test than a launch chart. In the public table, Kimi lands around 31% pass at 1, with an average cost of $2.82 per task. That is not frontier closed model performance. But it is also not useless. It is the uncomfortable middle, cheap enough to rerun, not reliable enough to blindly trust. The raw DeepSWE rows make the trade-off sharper. For the Kimi rows checked in the research, there were 452 matching full-scope trials through OpenRouter. 138 passed, 3014 failed the verifier. There were no run-level errors in that configuration. Average output was about 59,000 tokens, average peak context was about 132,000 tokens, and average agent length was 49 steps. That is a long agent run, not a chat answer with a unit test taped to it. The API behavior is one of the most important parts of this model. K2.7-Code always thinks. The docs say thinking cannot be disabled, and preserved thinking is always on. Historical assistant reasoning content has to be kept in the message history as is during multi-turn conversations. That can help coherence across tool calls. It can also punish a sloppy agent loop. If your harness drops the wrong assistant state, trims reasoning incorrectly, or treats tool turns like ordinary chat messages, you are not really testing K2.7-Code fairly. A 256K context window sounds like you can just shove the repo into the model and relax. Nope. That is how you build an expensive text landfill. The Kimi docs say reasoning content counts toward token consumption and occupies context when preserved. DeepSWE's Kimi runs also show large average input token volume and peak context over 100,000 tokens. Long context helps, but it does not replace context management. Agents still need compaction, file selection, log pruning, and a memory of what changed. Kimi also removes some knobs that developers usually love to pretend they tune scientifically. For K2.7-Code, the docs say temperature, top PN, and penalties are fixed. Tool choice is limited to auto or none. The docs also recommend streaming for thinking models, larger max token budgets for multi-step tool calls, retry logic, and low concurrency to avoid rate limits. That makes the benchmark contract clearer. You do not win by magic sampling settings. You win by building a durable agent loop. Open weights are still a real advantage here, just not the cartoon version. A 1 trillion parameter mixture of experts model is not something most developers are running casually under a desk. Even with native int4 quantization and serving examples, self-hosting means serious infrastructure, serving engine choices, memory planning, and operational work. But for privacy-sensitive teams, infra teams, and labs that want inspectable weights, that openness matters. The API is convenience. The weights are leverage. Moonshot's own numbers are encouraging. The model card reports K2.7-Code ahead of K2.6 on Kimi Code Bench v2, Program Bench, MLS Benchlight, Kimi Claw, and MCP-style tool use benchmarks. But several of those are first-party or in-house evaluations. The public tables do not give every patch, trajectory, failure case, or verifier log, so treat the launch benchmarks as a reason to test, not a reason to declare victory. For coding agents, receipts matter more than leaderboard shape. A fair Kimi benchmark should record the whole agent contract, name the provider, keep the harness fixed, preserve reasoning content exactly, record streaming, max tokens, retry policy, tool errors, test runs, patch attempts, input tokens, output tokens, cache tokens, peak context, and total cost. Then publish the trajectory, patch, logs, test output, and verifier result. That is the difference between the model seems smart and this agent completed 31% of these tasks at this cost with these failure modes. So, is Kimi K2.7-Code practical? My read is yes, but not as a drop-in replacement for the best closed coding agents. It is practical as a cheaper, rerunnable worker for bounded repo tasks, as a long context experiment, and as an open-weight option for teams with the infrastructure to use it. I would test it on real issues where verifier logs exist, where retries are allowed, and where cost per pass patch is the metric. I would not trust the spec sheet alone. The model is interesting because the benchmark contract is finally hard to ignore. If this helped you separate model hype from agent reality, like the video and subscribe to Fluid Coding and AI. The next useful test is not which model sounds smartest, it is which one can keep shipping correct patches after the easy demo ends.